Hi students, welcome to Math4U. Today let's see how can we do the operations on real numbers. This is from grade 9, chapter 1 number system. So we know already about real numbers, right? Real numbers contains both rational and irrational numbers. So let us see how can we do the operations. Before going into that, deep in what about rational numbers satisfies the commutative, associative, and distributive laws for addition and multiplication, right? However, the sum, difference, quotients, and products of irrational numbers not always be rational. Okay, so before going into the operations of these real numbers, let me discuss you with some identities. So the identities, first one is a root of AB. How can we do this? We can split it and write a root A into root B. Similarly, we can do root of A by B as a root A by root B. The third identity is that a root A plus a root B multiplied with a root A minus a root B. This is of the form you may be knowing A plus B into A minus B, right? What is A plus B into A minus B? This is A square minus B square. In this case, how can we write this? A root of A plus B into root A minus root B. Root A plus root B. Yeah. So that is A square. The first term square means a root A square minus the second term square, that is root B square. When we square, this root will go. So what will be the answer? A minus B. So we got it as a root A plus a root B multiplied with a root A minus a root B. That will be equal to A minus B. All right. Now let's move on to the fourth identity. What is the fourth identity? We can take a root A plus a root B multiplied with a root C plus a root D. What will be this? We have to open the bracket with each term from the first bracket. That is root A into root C, that is root AC, plus a root A into root D, that is a root AD, plus secondly the second term with the second bracket, that is a root B into root C is a root BC, plus a root B into root D is a root BD. This is how the operation going to happen. So what about the fifth identity? That is a root A plus a root B the whole square. How can we do this? You know what is A plus B the whole square, right? So A plus B the whole square is equal to A square plus, yes, 2AB plus B square. Very good. So same manner you can do this one also. So first term square, that is a root A the whole square, right? A root A the whole square plus 2 into root A into root B plus root B the whole square. So how can we write this? Therefore, root A plus root B the whole square, we can write it as what is a root A the whole square? That is A, right? The square root will go. Plus 2 into root A into root B. We have seen root A into root B, we can write it in one root, that is 2 into root AB, plus same manner here also root will go, that is B. So these are the main identities that we have to learn to do the operations on real numbers. Now let's go ahead with doing some addition on these real numbers. So I'm going to write the question over here and let's see how can we do it. Okay, so add 2 into root 3 minus 5 root 2 and root 3 plus 2 root 2. Okay, so this is like 2 into, yeah. So 2 into root 3 minus 5 root 2 plus root 3 plus 2 root 2. How can we do the addition of this? So let's see how can we do it. Okay, so I'm going to take this root 3 terms together and write this. First up we can put it in addition form, removing this and, okay, plus, and here root 3 plus 2 root 2. So as I told before, the root 2 I'm going to take together, that is 2 root 3 plus root 3. I'm just going to put this in one bracket plus what is the next? Yes, 2 root 2, and here you have to be very careful. There is one negative sign along with this 5 root 2. So I'm writing 2 root 2 minus 5 root 2. Okay, so what is the next step? Here you can see the root 3 is common. So what can we do? 2 root 3 and 1 root 3. What is the answer that you can get? I can take a root 3 as common and 2 plus 1 inside the bracket, plus I'm taking here root 2 as common and I'm going to write 2 minus 5. I hope this is clear. We took the common factor out and we have written the others inside the bracket. So it is like 2 plus 1 is 3. So I'm going to write the answer as 3 root 3. Here 2 minus 5 is how much? Yes, negative 3. So negative 3 root 2. So this is the final answer for the addition of 2 root 3 minus 5 root 2 and root 3 plus 2 root 2. Let's see one more. Okay, add, the second one is add 2 root 2 plus 5 root 3 minus 7 root 5, and the next one is 3 root 3 minus root 2 plus root 5. So how can we do the operation here? Let's see. So it is like 2 root 2 plus 5 root 3 minus 7 root 5 plus the next term is 3 root 3 minus root 2 plus root 5. So here I'm going to take the same root numbers together. That means here we have a root 2 here also. So I'm going to write it together. 2 root 2 minus root 2, next root 3 plus 5 root 3 is there, and plus 3 root 3 is also there. Again, next is minus 7 root 5 and plus root 5, right? Yes. So now what can we do? As I told, we can combine the same root terms together, or we can take the root 2 here common. Here you can take root 3 common and here root 5. So let me take a root 2 common first. So what will come inside the bracket? That is 2 minus 1 plus root 3 into 5 plus 3. Then next is, you have to listen very carefully here, what will come inside, okay, plus a root 5 into minus 7 plus 1. Okay, so first case 2 minus 1 is 1, so 1 into root 2 is a root 2, plus 5 plus 3 is 8, 8 plus root 3 is 8 root 3. Then here minus 1 plus minus 7 plus 1, okay, so that is minus 6, right? Minus 6 root 5. So this will be the final answer. Now let's see how can we multiply two numbers, real numbers here. Yeah. So the next is to multiply. Let's see how can we do. Multiply 3 root 28 by 2 root 7. How can we do the multiplication over here? Let's see. 3 root 28 multiplied with 2 root 7. So here we have the two roots, one is 28 and the other is 7. One main thing you have to understand, we can multiply these numbers together first. So that is 3 into 2 into root 28 into root 7. So how can we do this? 3 2s are 6, you know. This root 28 we can split in the form of a 7 table. What is that? Yes, 7 into 4. Then again we have root 7. So we can split 10, right? We have learned that a root of a into b, we can write it as a root of a into root b. That is root of a into b is equal to root a into root b. Same manner, I am going to split here the root of 7 into 4. 6 into root 7 into root 4 into here this root 7. Okay. So here two root 7 are there. So root 7 into root 7, we can write it as root 7 the whole square. And I have already told you, when a number is squared having a root, then it turns to the number itself. So we can write here 6 into 7 into root 4, you know, that is 2, right? So we will get the answer as 84. Is that clear? Yeah. Let's see one more. Yeah. So next is to multiply the two numbers. I'm going to give you two numbers. Multiply 3 root 8 by 3 root 2. So this is very easy. As I told you, have to split it and do. So 3 root 8 multiplied with 3 root 2. So first what we can do, we can multiply the numbers without a root. That is equal to 3 into 3 into root 8 multiplied with a root 2. So how can we split 8? Can we split it as 3 into 3 is 9 into root of 2 into 2, 4 2s are 8, right? Again a root 2. So this is of the form 9 into, you can see here a root 2, 2 root 2, root 2, root 2, again root 2. So you can write it like a root 2 into root 2 into root 2 into root 2, that is 4. How can we do? Because a root 2 into root 2 is what? Root 2 the whole square, that is 2. So 2 times same manners occurred. So 2 into 2, that is 4. So you will get the answer as 36 over here, right? Yes, very good. Now, how can we do the division on this? Let's see some properties like division. So divide 18 root 21 by 6 root 7. Let's see how can we do this. So I'm going to do it 18 root 21 by 6 root 7. So as I told earlier, we can do the calculation on the number which is not having a root first. So 18 and 6 you can cancel with 3 times, right? So I'm going to write 3 into root 21. You can split and write as root 7 into root 3, right? Divided by, you have 1 root 7 in the denominator. So again, you can cancel these two and you will get the answer as 3 root 3. Okay, this is very easy, right? Yeah. So another one more example, let me show you. Divide, yes, 12 root 5 by 4 root 3. So how can we do this? 12 root 5 by 4 root 3. Yeah. So this one I'm going to do it, okay, root 50. Okay, I will write over here. This is not 5, 50. Let me write. Yeah. So 12 root 15 by 4 root 3. So as I told you, you can do this cancellation first and you will get this as 3. Yeah. Then root 15 we can split as root 5 into root 3 divided by root 3. So these two will get cancelled and you will get the answer as 3 root 5, right? Now let's do some simplification. Okay. So I hope you are all ready now to go ahead and do this. So next is to simplify. First one is root 5 minus root 2 into root 2 minus root 3. Here we have to use the identity we already learned. So we have to open the bracket and you have to do it like that. Okay. So let's go ahead. So how you will open the bracket, first term into the first term of the second bracket, like that, first term of the first bracket to the first term of the second bracket. So like that you have to do the operation over here, right? Yes. So I can do it like a root 5 multiplied with the root 2, then with the second term in the second bracket, that is again multiplied with root 5 multiplied with negative root 3. Then what will be the operation here? Yeah, that you have to write it as positive. Yeah. And it will turn to negative because here you have the negative root 3, right? Then next is, again you can see here, I will use another one color, this one, negative root 2 into root 2. What will be the answer? Yes, you have to write negative root 2 into root 2. Again it comes like negative root 2 into, yes, negative root 3. So let's do the operation over here. So root 2 into root 5, you will get it as a root 10, yes, plus What will be the next term? Is it plus or minus root 5 into negative root 3? Yes, that will come as a negative because this number is having a negative sign. So that is a root 15. Then again, this will come root 2 into root 2 is 2 because you know root 2 multiplied with the root 2 will be root 2 the whole square. That will again turn to 2. So but here the sign is negative, so negative 2. Again you can see here negative root 2 and negative root 3. Obviously it will be a positive number, and root 2 into root 3 is root 6. I hope it is clear how to do the simplification. One more let's do. So the next is, I will write the question, simplify 3 plus root 3 into 2 plus root 2 the whole square. So you can see here the second is having a square. It is of the form now a plus b the whole square, right? So what is a plus b the whole square? We already seen that a square plus 2ab plus, yes, plus b square, right? So let's apply this over here. So now I'm just putting the same as the first bracket, 3 plus root 3, because we have to change the second bracket, right? So 2 square, a square is 2 square here, 2 square is, I'm just writing 2 square only now, plus 2 into a into b, that is 2 into 2. This 2, a, b is root 2, yes. Now this last term is root 2 the whole square, right? So this is how we can expand the second bracket. And let's solve the second bracket first. 3 plus root 3, I'm writing is same as such. Then 2 square is 4. Now 2 into 2 is 4. Again, you have here root 2. So plus 4 root 2. Then here, this will come as 2 root 2 the whole square is 2. Right? So we can add these two, right? Now the next step, I'm going to write it like 3 plus root 3, okay, plus 4 plus 2 is 6, 6 plus 4 root 2. Now what we can do? Now, as we done in the previous question, you have to open the bracket with each term, right? So first I'm going to open the bracket with this 3 into 6, right? 3 into 6 plus 3 into, next is 4 root 2, right? 3 into 4 root 2. Yeah, 3 into 4 root 2. Next we have to use for the second term in the first bracket with the second bracket, right? So root 3 into 6 plus root 3 into 6, then again plus root 3 into 4 root 2. Okay, root 3 into 4 root 2. Okay, so let's do this operation. Let's solve this one. So you can see here 3 6 are 18 plus 3 4s are 12, so plus 12 root 2, and here you can see plus 6 root 3, and here 4 into root 3 into root 2 is plus 4 root 6, right? So this is the answer what you will get when you simplify this. Is that clear? Yes, I hope it is very much clear how to do the operations. So this we have done, right? Now let me ask you, how can we solve if we get a root number on the denominator? We have to change this denominator into the rational form. That means now we know the root 2 is an irrational number. You have to convert it into the rational form to do the operation. So how can we do this? That is called rationalization of the denominator, right? That we will do in the next session. So I hope today's session is very much clear. Thank you.